Hello everyone, welcome back to my channel. Today let's go over another grind 75 medium question that I just solved on my own. So I'm really glad that I was able to come up with my own solution to this problem without any help. And yep, so let me show you how I did it. This one's called word search. It's a pretty famous question. And so basically you have this string word and you want to make the word if you can do it. So basically you can't use each cell more than once, and you just want to return true if you can make the entire word or not. Okay, so basically the idea is to loop through the board and run a DFS on every single cell and then go in all four directions without using more than one cell once, and then see if you can make the word. And then if we try all the cells, so we're going through each cell row by row. If we can't, then we return false. If we can, then we return true, right? So let's call this answer is DFS IJ because we're starting from the current cell, wherever that is. And then we have to define this, and we have to do our boundary checks. Zero or j is bigger than or equal to length of board of 0. And then also, remember, we can't use a cell more than once. So we're going to say, or board ij is equal to v, then we can just return. So we kill that recursive call because the way I did it is just to set this cell equal to v, and we have to store the original value because when we try all four directions, when we return from all four directions, we're going to come back to the current cell and we have to reset it to its original value, right? So let's call this a. This is going down, and cur plus 1. So we're going to actually include an index called cur, because cur is going to say, hey, how much progress have we made in the whole word? If we reach that length of the word, then we know we've matched every single cell, because we only move on to the next letter to the right if we've matched the current letter, if we found the current letter already, right? So okay, let's try up, and we're always cur plus 1 because this implies that we found the current letter we're looking for and we're ready to move to the right with this recursive call as we come back here. And then C is to the right, same thing. D is DFS I j plus 1, cur plus 1. Okay, and then obviously we have to reset the current cell because we're backtracking. We've tried all four directions. We're going to come back to the current cell equal to the original value, because this is just to make sure we haven't used it more than once in the current DFS call from here, right? So, and then we're going to return A or B or C or D because, again, we can find the current letter we're looking for. However we make progress, doesn't matter. It can be either one of the four directions, right? And so if answer, this is going to return a Boolean, is equal to true, then we can return true, right? Otherwise, at the end, if we can't, we tried the DFS from every single cell and we can't make up the whole word entirely, because we're going to say if cur is equal to length of word minus 1, then we've made progress all the way and we can just return true, right? So this is indicating that, hey, this was successful, so it's going to come back here, right? So let's run this. Okay, so supposed to be false. So if we can use the current cell more than once, so we also maybe want to have a set so we can't use the same letter cell more than once. So let's call this scene.add I of j, scene, and scene. Okay, so what we're going to do is also return false here. And then we're going to say if ij was already in scene, then we can't use that one. We have to backtrack, right? Okay, so there's still something a little bit wrong here. I'm not sure what it is. Let's print our answer. So we're going to make progress in all four directions. Oh, sorry, minus 1. That was the typo. Okay, I plus 1, I j minus 1, cur plus 1 and scene. So we might actually not, because this actually just says the scene, so we actually don't need this. So get rid of this. Okay, so still have something wrong here. So board of ij is equals to the original value. Yep, we're resetting that. So we return either this made progress or this one or this one or this one. So output is true when it's supposed to be false. Let's see how many test cases we're passing. 67 out of 88. So looks like this is true though. So maybe we can also just say if board of ij is equal to word of 0, then we actually just start at 1. Because then we can make progress. But I guess that's not what's going on. So let me debug this. Okay, so a plus 1, a, b, c, d. Yep, so we're trying to look for true in all 4 directions. Length of board 0 or reset it equal to v. Right, so if it's equal, yep, then it's going to be, oh, here it's 0. So still the same problem. Okay. So j is bigger than length of board 0, or the same letter cell may not be used more than once. Yep. So that's why we're marking it as v. And then coming back here, C or D. Okay. Yeah, this is interesting. Or if it's equal to length of word, maybe. No, because so cur is going to be 0, 1, 2, 3. So let's look at this example. ADE, so we're going to A, B, C, but we can't use this more than once, right? Because we marked that already. Yep, so forward ij is equal to v, yep. This is interesting, so I don't know why it's not passing now. J plus 1, so down, up, right, left. So maybe let's try, I don't think the order matters, but let's try I minus 1. Let's try this. Okay, yeah, the order doesn't matter because we're still looking for the word. So length of board I, maybe. Here is 0. This is weird. If answer So, okay, we have to basically say, if this is not equal to word of current, that was where I messed up, right? Because we have to match the word, right? So if this is not the correct letter we're looking for, I can't believe I missed that. Or board of ij is equal to v. Okay, cool. So I was looking at this. That's what I was thinking of. Okay, cool. And there you go. Passes all test cases. Yep. So again, really glad that I was able to come up with my own solution to this problem without any help and solve it on my own. So that's it for this video. Thank you for watching and stay tuned for more.